Hello and welcome to our Year 2 Mastery session for T-Level Science. Today we're going to be focusing on Inside the Mark Scheme for Assignment 1 in the Laboratory Sciences Occupational Specialisms. To start us off, here's what we're aiming to explore in today's recording. First, we'll work on strengthening your understanding of Assignment 1 expectations, breaking down exactly what each task is asked for and how it's assessed. We'll also build your confidence interpreting the mark scheme so you can see how the assessment language translates into what learners need to produce. We'll explore what good looks like by working with exemplar evidence, using grade examples to highlight the difference between pass and distinction responses. And finally, we'll identify the most common pitfalls students face, along with practical support strategies you can use in your delivery to help them avoid these issues and perform at their best. Let's start by breaking down Assignment 1 in detail. So Assignment 1 is a written submission that combines a literature review, planning documentation and evidence of how learners prepare for, plan and improve laboratory techniques. It's made up of 3 distinct tasks. Task 1, literature review, Task 2, SOP and hypothesis, and Task 3, risk assessment. In total, this assessment lasts 7 hours. It is worth 102 marks and makes up almost half, 47.9% of the overall occupational specialism grade. It's also worth noting that Assignment 1 is primarily assessed against Performance Outcome 2, which accounts for 90% of the marks, with a small element of PO1 in Task 2. If you look at the table, you can see the breakdown. Task 1 is 3 hours, worth 28 marks, focused entirely on Performance Outcome 2. Task 2 is also 3 hours, worth 58 marks, covering both Performance Outcome 1 and 2, and Task 3 is 1 hour, worth 16 marks and focused on Performance Outcome 2. Understanding this structure is crucial because it shows where the majority of the marks are available and how the performance outcomes are weighted. This will help you focus your teaching strategies where they'll have the greatest impact. Before we look deeper at the content of Task 1, it is important to understand the assessment controls that apply. First, the assessment is completed under supervised conditions, with no access to external resources beyond what is provided. This ensures the integrity and fairness of the process. Internet access is restricted to the specific sources provided as part of the assessment materials. Learners cannot go off and find their own references online. The Chief Examiner mentioned that in the ESP, many students have tried using online referencing software to reference sources and have, therefore, lost marks, as this is not allowed. So this is something that we don't want to see replicated within the Year 2 assignments. All work must be student authenticated and tutor verified. This means learners must confirm that the work is entirely their own and tutors need to verify that the conditions have been met. Finally, there is an externally marked and moderated assessment, so marking is carried out independently with moderation to ensure consistency and fairness across all learners and providers. Let's now focus in on Task 1 of Assignment 1, the literature review. In this part of the assessment, learners are required to research and critically evaluate relevant sources, selecting those that will support their planned laboratory investigation. We'll look at exactly how this task is assessed using the mark scheme to see where marks are gained and lost, and draw on graded exemplars to understand what a distinction level literature review looks like compared to a pass. We'll also identify the most common pitfall learners encounter in this task. So let's begin. So Task 1, mark scheme. What does a band 4 look like? When we talk about Band 4 for Task 1, we're looking for a literature review that not only lists sources, but justifies why each source is relevant and reliable. The justification covers several aspects. The type of source, is it primary or secondary, peer-reviewed or from a reliable journal? Author credibility, is the author a recognised expert, a scientist or a journalist? Method validity, are the experimental methods sound and relevant to the SOP? Commercial bias, does the author have a vested interest, such as working for a company that could benefit from the findings? And application to the SOP, does the source directly support the method that the learner is proposing? A Band 4 response also uses a correct referencing system and is presented in a clear, structured format. The work should be well laid out, accessible to a scientific audience, and clearly linked to the purpose of the task. It is important to note that Band 4 isn't just about including these points, it's about evaluating the literature, weighing strengths and weaknesses, and linking them directly to the planned investigation. Now let's look at the most common pitfalls we see in Task 1 and how these contrast with the distinction level work. On the left, we've got some of the weaker approaches. Weak critique, for example, saying it's a good source because it's on the BBC, without considering credibility, bias, or scientific validity. General summaries that don't link the literature back to the purpose of the investigation. Inaccurate or inconsistent referencing, which can lose marks. And no clear link between the literature review and the SOP design, meaning the research isn't driving the practical approach. On the right, we see what good looks like for distinction level responses. Under selection and valuation, learners clearly justify why sources are included or excluded, evaluate reliability, bias, authorship and validity, and differentiate between primary and secondary sources. Under application to SOP, the literature is clearly connected to method design, technique choices, and awareness of risk. And for structure and referencing, the review is professionally presented with appropriate headings and a consistent reference system, for example, Harvard, used accurately. The takeaway here is that high-level work doesn't just summarise, it evaluates, connects, and presents information in a way that clearly supports the practical task ahead. To help both staff and learners measure progress in Task 1, we can use a combination of simplified mark schemes, visual rubrics, and self-assessment tools. And we'll see this throughout the further two tasks. On the left, we've got a simplified mark scheme, breaking down the bands into clear what to look for points, from Band 4's thorough evaluation of sources through to Band 1 and 0 where there's little or no justification and scientific judgment is weak. In the middle, we've got a traffic light rubric. So this condenses the criteria even further. Green is excellent, all sources justified, strengths and weaknesses evaluated, bias and reliability considered, and direct links to the SOP made, with professional referencing. Amber is developing. Sources are described, but reasoning lacks depth and referencing may be inconsistent. And red is at risk. Sources are listed with no justification, minimal or no link to the task, and poor or missing referencing. Finally, you can also create a student self-assessment tool for Task 1. After completing the literature review, learners can tick against key checklist items, for example, whether they considered bias and authorship or linked literature to the SOP, marking themselves green, amber or red. So the question that I'd like you to reflect on, and which I'll get you consistently to reflect on throughout this session, where would most of your learners land right now? This will help you decide where to focus your teaching intervention strategies. So now we're going to look at an example of how you could structure Term 1 delivery to build learner skills. And then we'll move into Term 2. So we have based this on a 24-week process, so 14 weeks roughly for Term 1 and 10 weeks for Term 2 up to when the assessments begin. So in Week 1, we introduce Assignment 1 and Task 1 by unpacking the brief and mark scheme, looking at distinction versus past examples from the GSEMs and creating group summary posters. In Week 2, the focus is on types of sources, differentiating primary from secondary academic form, commercial, with a source spotting game where learners label and sort examples. In Week 3, we tackle source reliability. Learners use the literature list from the brief, take part in the Rate the Source Matrix activity, and discuss what makes a source strong or weak. Week 4 would cover bias, authorship and purpose. We use activities like the commercial or creditable exercise and a bias comparison sheet to identify and evaluate these factors in articles. Week 5 would be all about structure. We break down the GSEM, so the graded exemplars, layout for distinction responses, run a jigsaw activity to reorder an exemplar and introduce a standard review structure. intro, review, links, conclusion. In week 6, we focus on referencing bias, introducing Harvard referencing, running a spot the error quiz, and giving learners practice citing real sources. And finally, in week 7, we help learners extract information for their SOP using the Lit to SOP grid. They record how literature supports method, safety or results, and take part in a classroom brainstorm to decide which sources are best for different decisions. In the second half of term 1, the focus shifts from building knowledge to applying it more actively and independently. So in week 8, we work on justifying literature. Learners use sentence scaffolds like "this source is appropriate because," and practice writing short paragraphs justifying inclusion or exclusion. Week 9 is about comparing sources. Learners take 2 contrasting sources and write and compare and contrast paragraphs, followed by peer critique using sentence frames for support. In week 10, we bring this together into a mini write-up task. Learners choose 2 sources from the brief and write a short literature review with full structured referencing and justification. This serves as a midpoint application task. Week 11 focuses on peer feedback and redrafting, using the traffic light rubric and simplified mark scheme. Learners identified strength and development points in each other's work. Week 12 is a tutor-led modelling, where the tutor takes a live past level response and upgrades it to distinction standard, showing how to strengthen language, structure and logic. Learners then edit weaker sections of model text themselves. In week 13, we consolidate through retrieval and fluency activities, using low-stake quizzes and flashcards to reinforce key concepts like source types, referencing, bias evaluation and SOP links. Finally, week 14 is consolidation and reflection. Learners create their own How to Nail the Literature Review guide, set goals for term 2 and share takeaways from the GSEMS insights. This sets them up to approach the assessment with confidence and a clear plan. In term 2, we start moving learners from supported practice into full assessment readiness. In week 1, we recap and run a skills audit. Learners colour code the rubric based on their confidence, then build a group mind map of what a Band 4 response, drawing from the mark scheme and GSEMS. Week 2 is all about linking literature to SOP. Learners return to the task 1 brief, complete the which part of the SOP is influenced by this source activity, and use exemplar material to see strong explicit links. In week 3, we plan the full response using a scaffold, intro, key literature, evaluation, application, conclusion. Student plans with 3 or 4 strong sources. Week 4 is their first time supervised mock, practicing correct headings, word processing and file naming under the assessment-like conditions. In week 5, we embed peer assessments. Students use the traffic light tool and a simplified rubric to match their work to the closest GSEM sample and see where they sit on the path to distinction scale. Week 6 is a targeted tutorials, small groups based on need. For example, improving referencing, strengthening evaluation, or clarifying SOP links, followed by redrafting with tutor feedback. Week 7 focuses on referencing and proofing. Learners check tone, layout and referencing consistency against the checklist before submission. Week 8 is the final full task 1 under timed exam conditions, submitted in the official brief format to stimulate real assessment. Week 9 is marking and moderation. Tutors use the real mark scheme, compare to GSEM exemplars and provide detailed feedback so learners can agree their final improvement. Finally, week 10 bridges into tasks by using what decision will your SOP be based on from the review, and create a lit to SOP flowchart, reinforcing that task 1 is directly informs the next stage of the assessment. So now we're moving into assignment 1, task 2, the SOP and hypothesis. This is the largest single task in assignment 1. Worth 58 marks and split across performance outcome 1 and performance outcome 2. It assesses both the learner's ability to plan a practical investigation and the ability to apply safety, method and analysis skills with precision. Task 2 focuses on producing a high quality standard operating procedure underpinned by a robust hypothesis. The distinction standard has 6 key components we need to teach and reinforce. Hypothesis. This must be scientifically sound, testable and justified using both the context of the task and relevant literature from task 1. Equipment and regions. Learners must provide an accurate, complete and specific list that directly reflects the method they're proposing. Generic or incomplete lists won't meet the higher bands. Safe working practices. These need to be embedded within the method, not just listed separately. They should be clear and specific with references to PPE, fume couplers, COSH awareness, and any other task-specific safety protocols. Step-by-step SOP. This method must be logically sequenced, clearly written, and inclusive of calibration, control measures, and adjustments to settings. Data collection and calibration. So the SOP should detail how data will be collected, the calibration process, and the tools used to ensure accuracy. For analysis and statistical justification, a distinction level learner must not only explain the statistical techniques used, such as mean, standard deviation, or calibration curves, but also interpret what those findings mean in relation to the investigation, for example, copper yield. A consistent referencing system and a professional structured format are non-negotiable for high-band achievements. Your job in teaching this is to break these elements down into manageable skill sets so students can build them progressively across term 1 and 2. And similar to assignment 1, I will show you how to do this, how you could do it. So let's explore some common pitfalls for task 2. Beginning with hypothesis. Too vague or generic. I think there will be copper rather than a clear testable prediction linked to method. No justification. Fails to use literature review findings or context from the brief. Missing link to data collection. Hypothesis not tied to how concentration or mass will be determined. SOP structure and content. So missing or incomplete steps. Key stages of method not described or steps out of logical order. No calibration or control details. Omits how equipment will be calibrated or how results will be validated. Overall generic methods. SOPs could be for any experiment, not specific to phytomining copper concentration. Wrong or missing equipment regions. Critical items such as water bath, colorimeter, filter paper, absent. Unrealistic and unsafe steps, e.g. heating acids over open flame when safer alternatives exist. Next, safe working practices. Only lists PPE. Lacks explanation of why each practice is required. No integration into SOP. Safety separated entirely instead of embedded into relevant steps. Misses key hazards, for example, handling of acids, disposal of copper solutions, or use of electrical equipment. Next, data collection analysis. No clear link to hypothesis. Data collection plan doesn't address the prediction. Missing statistical methods. Fails to specify or justify tools like mean, standard deviation, calibration curves. Vague analysis instructions. For example, record data and work out the average without detail on units, graph types or calculations. And incorrect or irrelevant calculations using wrong formulas for concentration or mass. And finally, general presentation issues. Lacks professional formatting, such as headings, numbering, and clear sections missings. No link to task 1. Ignores information gathered in the literature review when designing the SOP. Inconsistent scientific terminology, mixes casual language with technical terms. And finally, poor alignment with assessment brief. Method does not match the scenario requirements. Again, so similar to assignment 1, task 1, on this side you can see 3 tools working together to help learners aim for high performance in task 2 and to measure progress. Again, on the left we have the simplified mark scheme, which distills the formal criteria into plain actionable look-fors. For example, the hypothesis needs to be clearly stated, justified with context and literature, the equipment list must be complete and accurate, Safe working practices should be specific and hazard-free. The SOP should be step-by-step, logical, and include calibration and controls, and data analysis must explain the use of statistical tools and link findings back to things such as copper yield. Again, in the right, we have the traffic light rubrics. Again, this will translate those expectations into quick visual scales, with green indicating excellent work, fully justified, complete and aligned to the method. Amber means developing, so partial complete, missing detail or lacking clarity, and red signals at-risk work, so unclear, incomplete, unsafe or without meaningful analysis. This again will make it easy for learners and yourself to identify exactly where improvement needs. And finally, we have a student self-assessment tool, which mirrors the rubric and mark scheme, but in learner-friendly checklist language. Students are green for confident, amber for partial, or red for need work. Again, this will encourage reflection before submission and builds assessment literacy by using the same judgment language as the marking process. And again, as you look at this, think about your own group. If they completed this today, where would most of them land? Green, amber or red? That reflection can guide your next steps in supporting and teaching focus. So again, we're going to look at a detailed plan for Term 1 and Term 2 on how we can build that knowledge and skills to achieve the Band 4 in Task 2. So in week 1, we would introduce Task 2 by breaking down the brief in the mark scheme, showing learners exactly what a distinction SOP looks like compared to a pass. We'll also highlight common pitfalls so they know what to avoid from the outset. In week 2, we concentrate on understanding hypotheses, teaching what makes a testable, justified hypothesis and having learners rewrite vague examples in Band 4 versions. Week 3, build the bridge between Task 1 and 2, using literature from Task 1 to justify hypothesis choice and mapping these insights directly to SOP planning. In week 4, we move into equipment and regions. Learners will create detailed kit checklists and correct any errors in selection to match the distinction standards for completeness and relevance. Week 5 would introduce the safe working practices with hazard identification for each SOP step and many case studies, ensuring learners embed safety steps into the method rather than listing them separately. In week 6, we unpack SOP structure. Students dissect distinction SOP into logical steps, practice reordering scrambled SOPs, and learn how to number and sequence instructions clearly. In week 7, we introduce calibration and controls. This includes demonstrations of equipment calibration, drafting SOP calibration steps, and ensuring these are specific and accurate. Week 8 focuses on method specificity, moving from vague to precise language, followed by peer editing for clarity. In week 9, we work on data collection plans, including how to set up calibration curves and plan headings, units, and tables in advance. Week 10 introduces statistical tools such as mean, standard deviation, and calibration curves, and discuss why they're relevant for hypothesis testing. Week 11 is about embedding safety within SOP steps, integrating it logically rather than treating it as a separate add-on. Week 12 is a mock SOP writing week. Learners will produce a simplified SOP covering the hypothesis, kit, safety, and analysis plan under supportive conditions. In week 13, we use peer assessment with a simplified rubric followed by an upgrade activity to push responses to Band 4. And finally, in this term, week 14 would consolidate the learning with a mini assessment covering hypothesis writing, kit selection and analysis planning, ensuring learners are ready to apply these skills independently moving forward into term 2. So again, in term 2, the focus shifts from building skills to applying them under assessment conditions. We work towards learners producing a complete SOP independently and confidently. So week 1, recap and skill audit. We begin with a self-assessment against the mark scheme, identifying target areas for improvement. Week 2, SOP planning from Task 1 outputs. Learners directly use their Task 1 literature reviews to inform and justify their SOP design. Week 3, full draft SOP. A complete SOP is drafted with the tutor circulating to provide immediate formative feedback. Week 4 would be peer review, so SOPs are swapped, reviewed using the rubric and compared to GSEM exemplars to identify gaps. We ran in week 5 improve weak areas, so we run small targeted group sessions focused on the weakest components for each learner, whether that's hypothesis, equipment, safety or analysis. In week 6 we move to time section practice. Students practice writing just the hypothesis and method in time conditions, reviewing for accuracy and completeness. Week 7 will be a final SOP rehearsal. A full SOP is written under mock assessment conditions, then self-marked using the rubric. Week 8, review and feedback. We run one-to-one review sessions focusing on safe practice integration and clarity in data analysis. And week 9, full task simulations. Students complete the full task 2 under 3 hours supervised conditions to replicate the exam environment. With week 10, tutors mark against the real mark scheme, learners compare the performance to GSEM exemplars, and you plan how these skills will transition into task 3. We're now moving on to task 3 of assignment 1, which focuses on risk assessment. This task is designed to test how accurately students can evaluate potential hazards, prioritise them and apply effective control measures. It builds on understanding of safe practices from earlier tasks, but here the focus is on analysing and justifying decisions in a clear structured format. By the end of this section, students should be confident in identifying risks, applying the hierarchy of control and integrating caution disposal requirements into responses. Keep in mind, clarity, accuracy and structure will make a big difference to any marks here. So let's explore risk assessment essentials. For distinction level responses in task 3, students need to meet several key criteria. First, under hazard identifications, students should identify a full range of realistic hazards. That means chemicals, equipment, biological and procedural risks. Next, in the hierarchy of risks, hazards should be prioritised logically using a likelihood and multiplied by severity approach, with clear reasoning for why they've ordered them in that way. For control measures, strategies must be practical, specific and effective. This includes the use of PPE, procedural controls and cost considerations where relevant. Finally, waste disposal and legal compliance needs to be addressed. Students should detail safe disposal methods that align with both environmental and legal standards and include appropriate references to HSE or COSH guidance. Remember, the work must use a referencing system and a structured format. That means not only getting the safety content correct, but also presenting it professionally so it's easy for an assessor to follow. So again, let's explore some common pitfalls, but for task 3. Beginning with hazard identification. Incomplete hazard list fails to cover chemical, equipment, procedural and environmental hazards relevant to the SOP. Over generic hazards, for example, chemical or equipment, with no specific details. For example, sulfuric acid is corrosive or calorimeter could be an electrical hazard. Misses environmental risks. No mention of waste disposal or environmental contamination. For hierarchy of risk is not prioritised, treats all risks as equal rather than assessing the likelihood multiplied by severity. No explanation of priority, lists numbered in the matrix but doesn't justify why one risk is higher than the other. Incorrect risking score, applies wrong values in the matrix or inconsistent scoring between similar hazards. Moving on to control measures. So vague controls, wear PPE without specifying type and when it should be used. Impractical or irrelevant controls, measures that won't work in the given lab context. No link to hierarchy of control, doesn't consider elimination, substitution, engineering controls before PPE. Not linked to specific hazard, control measures written as generic lab safety tips. Moving on to legislation and compliance, no reference to COSH, especially for things like sulfuric acid, copper compounds or hazardous waste. Omission of disposal requirements, so no mention of safe waste handling for things such as copper solutions or contaminated materials. No alignment with SOP steps, so hazards and controls don't match the actual method that the student wrote in task 2. And finally, quality of explanation. So too brief, lists hazards and controls with no reasoning, no connection to the why, doesn't explain how the control reduces the risk, and inconsistent details, such as some hazards explained well but others barely addressed. So again, on this slide, we're going to explore how to measure in task 3 using the simplified mark scheme, a traffic light rubric and the self-assessment checklist. So looking at the mark scheme on the left, a band 4 response worth 13 to 16 marks will evaluate risks with clear priorities, suggest practical controls and fully justify those measures. It would also include COSH, PPE and disposal guidance. Band 3 shows more reasoning but less depth. Band 2 offers only basic controls with limited prioritisation, and Band 1 lists just a few vague risks with no clear structure. 0 marks are given where content is invalid or unsafe. On the right is the traffic light rubrics. So green means all hazards are identified and prioritised, controls are justified and COSH or disposal guidance is included. Amber is where general hazards are listed with basic control and there's some logic but not enough depth. In red is where few risks are listed, the controls are vague and there's no prioritisation. And finally, we have the student self-assessment tool for task 3. Learners can use this to check that they've listed all relevant hazards, prioritise them using the likelihood multiplied by severity, explain controlled measures for each hazard, and included safe disposal and COSH where needed. And again, finally, you can ask yourself, where would most of my learners currently land on this rubric? And what steps will help them move towards band 4, the green performance? So we're going to explore a final delivery plan but for task 3, and hopefully you can combine these 3 delivery plans so that they run alongside each other to help develop the tasks in parallel. So in week 1 we start by introducing the task 3 brief and mark scheme, highlighting the difference between pass and distinction examples from the GSIM. This helps learners understand the quality expected and how task 3 link to their SOP in task 2. Week 2 moves into hazard identification basics. We introduce the 4 main categories: chemical, equipment, procedural, environmental, and use interactive activities like a hazard hunt to make this hands-on. In week 3 we focus on COSH awareness. Students learn the key symbols, their meanings, and apply this through case studies such as disposal of copper sulfate. Week 4 is about hazard specificity. Students practice refining vague hazard descriptions into precise, accurate statements, then prioritise them in group activities. In week 5, we teach how to use risk matrices, applying the likelihood multiplied by severity scoring to real examples and exploring common scoring mistakes. Week 6 covers the hierarchy of control, starting from elimination and moving down to PPE, then sorting real-world control examples into the hierarchy. And in week 7, this bridges the gap between hazard identification and SOP steps. Students map hazards directly to SOP draft stages and match hazards to the relevant control measures. In the second half of the term, we focus on control measures, application and drafting full risk assessments. So in week 8, we strengthen students' ability to justify control measures, explaining clearly how and why each control reduces risk. This includes upgrading weaker pass level control statements. Week 9 focuses on disposal and environmental safety. Students learn safe disposal methods for specific chemicals, contaminated PPE and sharps, linking to legislation and environmental regulations. Week 10 is the first draft stage. Students create a hazard list and assign risk scores for a simplified practical. In week 11, they add control measures and justifications, followed by a peer review against the mark scheme. Week 12 covers risk assessment templates and formatting, how to lay out their work using the proforma from the brief so it's professional, clear and assessor friendly. In week 13, we add a live practical link. Students observe as demonstration, then practice writing hazards and controls in context. And finally, in week 14 is for review and for reflection. Students have self-assessed their risk assessment using the traffic light tool and set 3 improvement goals for term 2, ready for more independent application. So in term 2, our focus shifts to applying the risk assessment skills from term 1 into task 3 and linking them more directly with learners' own SOPs. So in week 1, we will start the term with a recap of the core skills. This could include a quick-fire hazard identification challenge to refresh their knowledge and review of the hierarchy of controls to make sure they're still confident in the basics. In week 2, learners work directly from their own SOP created in task 2. They identify hazards at each stage of their method, ensuring relevance and authenticity. This reinforces the link between the SOP and risk assessment, which is critical for achieving distinction level work. Week 3 is about prioritising risks. Learners score the hazards they've identified, then justify the top 3 highest priority tasks, developing the reasoning required for Band 4. In week 4, we focus on writing strong controls, moving from vague statements to precise legislative compliant controls. We also explicitly embed legislative references, ensuring controls meet professional standards. In week 5, we concentrate on embedding disposal steps into their work. Learners must include waste handling at the correct stage of their SOP and cross-check against legislation, aiming for distinction level compliance. Moving into the second half of this term, we start week 6 with a timed draft of the full risk assessment. This 1-hour assessment simulation helps learners experience the pace and structure of the actual assessment conditions. In week 7, we run peer and tutor feedback sessions. Learners use this simplified mark scheme to peer assess, then compare their work to GSEM Band 4 sample. This combination of self-evaluation and model comparison builds their ability to spot and close gaps. Week 8 is a targeted improvement week. Tutorials focus on the feature most often missed in Band 4 work: clear justification, precise disposal steps, and control specificity. Week 9 is the final practice before the assessment. Learners complete the full risk assessment using both their SOP and Task 1 context under full mock conditions, giving them a realistic pre-assessment experience. And in week 10, we close that loop with marking and reflection. Tutors mark against the full criteria, learners compare to GSEM expectation, and then identify transferable skills they can take forward into Task 3 and other units. So as we come to the end of today's section, I'd like to take a moment to reflect on some common themes we've seen and share some practical ways you can take this forward into your own teaching and delivery. So looking across provider feedback and student performance, there are some recurring focus areas. First, we'll see generic or irrelevant sources being used in SOPs, which weakens the credibility of the work. Second, SOP steps are often incomplete, missing key details for practical replication. Third, risk assessments can sometimes feel like simple checklists rather than a considered, prioritised analysis. And finally, analysis is either omitted or lacks clear justification. So how do we address these? Looking ahead, there are several strategies. Teach critique by comparing side-by-side sources. Students can see the difference between weak and strong evidence. Use SOP structured frames and walkthroughs to give clear model to follow. Provide risk assessment templates with a built-in hazard hierarchy, mini task to reinforce prioritization. Give students opportunities to practice interpreting exemplar responses. And you can also implement simple but powerful tools that I have shared throughout this session, such as the traffic light rubrics to guide moderation discussions, self-assessment prompts for student reflection, and using a simplified mark scheme as a classroom modelling tool. So this slide shows the full Year 2 Mastery series for T-level science mapped across terms 1 and 2. So we began in September with our first virtual session inside the mark scheme, assignment 1, which set the tone for high quality delivery and understanding of assessment expectation. In October, we release our Chief Examiner Insight bite-sized recordings, short, targeted videos highlighting key strengths and common areas for development from recent assessment series. Then in late November, we have a face-to-face funded event focusing on industry insights with ETF alongside an assignment 2 planning surgery, where we work through real examples to strengthen delivery. By December, all 3 assignment bite-sized recordings will be available for you to access on demand so you can revisit them at any point in the year. Moving into term 2, in March, we run our second virtual session from feedback to improvement, assignment 3. This focuses on interpreting feedback effectively and translating it into concrete learner progress. And throughout the year, we run ongoing drop-in clinics, open opportunities to bring questions, share challenges, and learn from each other. So where can you access this support? So it doesn't stop at the end after this session. So there's a range of materials to help you and your learners. So on the NCFE qualification page, you'll find the Chief Exam reports, the student exemplar work, and downloadable teaching materials. There are also recorded CPD sessions like this on our YouTube playlist, which you can revisit anytime, and upcoming live events as shared previously, which is listed on our T-level events page. All these are designed to make your delivery smoother and your learners more confident. So before we finish, I would really appreciate your feedback on today's session. You can scan the QR code on the screen or follow the link which is in the description as well of this video for a very short survey. Please put in T-Level Science Year 2 Mastery inside the Mark Scheme Assignment 1 as the event title. Your input helps us refine our training and make sure future sessions are as relevant and as useful as possible. So thank you for your time and engagement today. I hope you leave with some clear practical strategies to support your learners in achieving their best. Please do make use of some of the resources suggested, and remember, small consistent changes in delivery can make a big difference to learner outcomes. Thank you again, and I look forward to seeing you at some of our future sessions.